Oh yeah. Any questions? So, yeah.
Hi, Elon. Irene Klotz with Aviation Week. Can you hear me?
Yep.
Thank you for the overview. Can you tell us a little bit more details about the flight test program for this and the Mark II?
Actually, can we just turn the music off? I can't quite hear because there's music playing. Oh, excellent. No, sorry. Could you probably just say that again?
Yes, thank you. Can you talk a little bit more details about the flight test program for both this Mark I and the Mark II vehicle in Florida, and what the progression is to get to orbital flight and then a test flight or a commercial mission with the full vehicle?
Sure.
Thanks.
So, yep, with any development into uncharted territory, it is difficult to predict these things with precision. But I do think things are going to move very fast. So our plan is in basically 1 to 2 months to do the 20-kilometer or 65-foot flight with Starship Mark I. Our next flight after that might actually just be all the way to orbit with a booster and the ship. I'm giving you just literally stream of consciousness here. Most likely we would not fly to orbit with Mark I, but we would fly to orbit with Mark III, which will be built after Mark I right here. In fact, we'll start building it in about a month. So, yeah. And actually, so sorry to say this mid-question, but I did want to make sure to thank Yusaku Miyazawa for his great support. Yeah, he's awesome. Yusak 2020, that's his handle. That's a great handle. Anyway, he's a super cool dude, and he's like, putting a lot of serious resources to helping out Starship. So I want to thank him very much for that. Anyway, so yeah, just to frame things, we are going to be building ships and boosters at both Boca and the Cape as fast as we can. And each successive, yeah, absolutely. I mean, it's going to be really nutty to see a bunch of these things. I mean, not just one, but a whole stack of them. And we're improving both the design and the manufacturing method exponentially. So, for example, with the current way that we build or the way that Mark I and Mark II cylindrical sections were built was in with basically plates. So a series of plates to create each cylinder section. With Mark III and beyond, we will literally take the coil of steel from the mill, unspool it, change the curvature to a 9-meter diameter, and do a single seam weld. And it would also be thinner, which makes it lighter and cheaper. So the rate at which we will be building ships is going to be quite crazy by space standards. I think we'll probably have Mark II built within a couple of months or less, and Mark III maybe 3 months, that type of thing. Mark IV, 4 months, maybe 5 months. And we would seek to go to orbit with probably Mark IV or Mark V. So we would, I mean, this is going to sound totally nuts, but I think we want to try to reach orbit in less than 6 months. I mean, provided the rate of design improvement and manufacturing improvement continues to be exponential, I think that is, accurate to within a few months. Yeah.
Hi, Elon. My name is Steve Clark. I'm with the Brownsville Herald.
Okay.
Back in September 2014 at the groundbreaking, you said that the first crewed interplanetary mission could possibly leave
Yes.
Can you hear me? Could possibly leave from Boca Chica. Do you think that's still the case?
Yes, that is, I think, definitely possible that the first crewed mission on Starship could leave from Boca. We actually are internally competing the Cape and Boca. So I think both places will, to the best of my knowledge, both places will launch crewed missions. So I think it is extremely likely that we will launch crewed missions from Boca, and there is at least a 50% chance that it is the first mission. Yeah.
Thank you very much.
Hey, Elon, Tim Dodd, the Everyday Astronaut.
Hey,
how are you?
How's it going? Good. Yeah,
Good.
You have great questions online.
Thanks. You have
Yeah.
great answers.
Yeah, welcome.
So that belly flop to tail down maneuver, I
Yeah.
mean, that's something to see. Is that first one, this one right here, 20 kilometers, is it going to come in that hot and do that flip that fast right here, or is it going to be out on the drone ship? Like, that's
No,
crazy.
it's basically right where Hopper took off.
Yeah.
That's basically where it's going to take off. Within, very close to where it's just right over there. So yeah, that maneuver that you saw, it will execute now. When we get to, I think maybe Mark 3, certainly Mark 4, I think probably that will be a good time to transition to hot gas thrusters from cold gas thrusters. So using essentially compressed nitrogen gas as the cold gas thruster is a pretty low ISP, sort of 60, 70 if you're very lucky, but very closer to 60. With methox thruster, you can get, without really even trying hard, 300 ISP. Even if you just film cool the walls, without even regen cooling. If you regen cool it, 350, no problem, 360 even. So you're talking about something that's then 5 or 6 times the mass efficiency of the nitrogen thrusters that are on Mach 1. And if you have thrusters of that efficiency, then we don't need to use the Raptors to correct the horizontal velocity. Because right now it's actually, when the Raptors fire, the Raptors kick it over, but they actually accelerate the vehicle in the wrong direction. Then they have to overcorrect and then come back. Whereas if you have strong enough thrusters, you can just, using the onboard maneuvering thrusters without lighting the main engines, you can just go kick it hard, light the engine, land. That'd be, that's better. Yeah.
And then are those pressure fed then, those metalox?
Yeah. Those would be just pressure fed, high pressure gas methox, and so you'd have a high pressure CH4 bottle, high pressure O2 bottle, and then the great thing is like those they don't care what attitude you're at. You can be at any attitude, any G's, any attitude, it'll still fire. Yeah.
Awesome.
Yeah.
Thank you.
Yeah.
Hi, Elon. I'm Tim Fernholz from Quartz. Thanks so much for taking the time.
You're welcome.
2 questions, if I may. One, just technical, following up on the presentation. To do useful stuff in orbit, you're going to need the booster as well as the Starship, right?
Yes. Starship cannot get to Earth orbit without the booster. But anywhere except Earth, pretty much. Well, not counting Venus. But like the Mars or the Moon, the ship, provided you have a propellant plant on Mars or Moon, the ship can easily get a single stage from the surface of the Moon all the way to the surface of Earth without a booster. So that shows you how deep, like Earth has a deep gravity well and a thick atmosphere. But definitely cannot, if we really went crazy light, you could probably do single stage to orbit non-reusable with the ship. But that would be pointless.
Elon, I just wanted to ask, NASA Administrator Jim Bridenstine had a tweet last night about this presentation, concerned, I guess, about enthusiasm for SpaceX's various programs. I'm just curious if you have any comment or response to that.
Yeah, we, for sure, from a SpaceX resource standpoint, our resources are overwhelmingly on Falcon and Dragon. Let's be clear, it was really quite a small percentage of SpaceX that did Starship, less than 5% of the company, basically. The really hard part that requires a lot of resources is optimizing something past the initial prototype phase and bringing it into volume production. To be clear, the vast majority of our resources are on Dragon and Falcon, especially Crew Dragon.
Thank you.
Yeah.
Hey, Elon. Chris Gebhardt with NASA Spaceflight. How do you guys envision keeping the methane and oxygen inside the tanks from boiling off in any significant quantity during a multi-month interplanetary trip to Mars? And on a more Earth-grounded question, what's your contamination mitigation strategy since these things are being built outside in the elements and not in a factory?
Well, these are pretty far in the distance questions. These questions are relevant, but in the future years. Keeping the landing propellant cold on the way to Mars is a lot easier than it may seem, because you can essentially vacuum, just like you'd keep cryogenic propellant stored on Earth for long periods of time. You vacuum jacket it. We would essentially have header tanks that are bigger than these header tanks, and vent them to vacuum. So you would just basically have a tank inside a tank with multi-layer insulation, and this way you can keep things cryogenic for months, no problem. It requires very little energy you don't even really need to worry about boil off. You could apply some energy to cryo-cool it, but you don't really need to. You'd have a tiny amount of boil off. In vacuum, things are kind of weird. They're not like on Earth because you have no convective cooling, really, in zero G. So you actually have the sun side of your rocket is very hot, and the not sun side of your rocket is at 3 degrees Kelvin. So it's super cold. So you just keep your cold stuff on the cold side and the hot stuff on the hot side, and this is not a problem to manage. For the long-term stuff, for sort of what's called contamination of Mars, I think this concern. First of all, we'll do everything we can to mitigate it, obviously. But at the end of the day, if you're going to send people to Mars, that's a pretty big contaminant, But I really don't think that some Earth-based bacterium is going to be able to migrate much through Mars. The thing that makes Mars very difficult is that it is both cold and has high ultraviolet. So if it was either cold or ultraviolet, you could evolve to deal with it. But the cold slows down metabolic processes, and then the ultraviolet shreds the DNA. So you're cold and shredded. This is very difficult for things to exist on the surface of Mars, and that's why we have not found any traces of life on the surface of Mars to date. If there is any life, it'll be very deep underground, and I think very resilient. Yeah.
Cool. Thank you.
All right. It's also worth noting that over time there have been meteors. There have been chunks of Earth that have been chipped off by meteors, and chunks of Mars that have been chipped off from Mars. And Earth and Mars have actually exchanged material many times over the last several hundred million years.
Hey, Elon, it's Chris Davenport from the Washington Post.
Hey.
Curious about your vision for this area. I mean, when you drive by and you see this, it's surreal.
This is surreal.
Yeah, but I know your vision isn't maybe like a government launch site, like a Cape Canaveral. But what does this look like a private, operational, commercial spaceport?
Yeah, I mean, it will definitely get fancier than it currently is, because the reason it's not fancier is just because it would have taken too long to build the buildings. So since it was going to take so long to build the buildings, we just built it outside. Yeah, this is like my new thing is management by rhyming. If the schedule's long, it's wrong, and if it's tight, it's right. Yeah. It works. SR-71, fastest plane in history ever. It's also the coolest plane ever. It had no anti-missile defenses except one: accelerate. Yeah. Zero. They tried to shoot it down many times. 0 successes.
just give us a quick sense of what you think this area will look like in, say, 10 years when you are flying crews?
Oh, I think it'll be like a lot more buildings and a lot more stuff. Like way more stuff than is currently here. As you can tell, the wind is really quite vigorous. Like one of the things that I think will be quite important to have locally is propellant production. So trucking massive, thousands of tons of liquid oxygen to the site doesn't make a ton of sense. We should really produce the liquid oxygen here. And by the way, we have gaseous oxygen in the atmosphere, so we basically just need electricity. I forgot to mention, one of the things over time is, like for the propellant production on Mars will be completely renewable because we will use solar panels, pull the CO2 out of the atmosphere. Mars has a primarily CO2 atmosphere. Get the H2O, the water, from the ice. Mars has a massive amount of ice. You combine H2O and CO2, and you get CH4 and O2. There's a very long understood process of run it over ruthenium catalyst. This is a Sabatier process to create CH4 and O2 out of CO2 and H2O. And that same system that we developed for Mars will long-term be used on Earth. So long-term, this is like, long-term we will produce the propellant for the rockets using solar power. And pull the CO2 from Earth's atmosphere, use water, combine that to create CH4 and O2 on Earth. And so the long-term outcome will be quite sustainable and renewable for Earth and Mars.
Jeff Faust of Space News. You spent a lot of time this summer working with the FAA, getting approval to do a single Starhopper flight to 150 meters. Now you're talking about flying a much bigger vehicle to much higher altitudes and ultimately flying to orbit. Where are you in the FAA in terms of getting approval for that? And will those flight opportunities be able to coexist with, say, the local residents around here?
Yeah, I mean, I'd say the FAA Administrator for Space has been excellent to work with. Very forward-leaning. Really, I would just like to say thanks to the FAA for their support, actually. I mean, really, there's, minimal delays related to regulatory activity, and they've been really very reasonable, and so, the support's very much appreciated. So, I think the FAA asks, good questions and wants to make sure things are safe, as do we. And so we're going to make sure that the risk to the public is extremely, vanishingly small, almost nothing, basically. It's the same sort of thing that we've had that we deal with on Falcon 9 and Dragon, and has gone very well, for the 17 years that SpaceX has been around. So I feel pretty optimistic about things. I don't see any fundamental obstacles. We are working with the residents of Boca Chica Village because we think over time it's going to be quite disruptive to living in Boca Chica Village because it'll end up needing to get cleared for safety a lot of times. So I'd say probably not very. There would be just not very comforting to the Boca Chica Village. I think the actual danger to Boca Chica Village is low, but it's not tiny. So therefore, we want super tiny risk. So, probably over time, better to buy out the villages, and we've made an offer to that effect. Yeah.
Thank you, Elon. It's Tarek Malik from Space.com. And I was curious, with the design update here, if 100-person crew size for base flights is still kind of the target now, and how the life support...
Sorry, could you talk a bit louder? The wind is like howling in my ear, unfortunately.
Sure. Yes, with the design update here, I'm curious if the 100-person crew size target is still the main target for base crew flights, and how the life support system for that is being developed for both the initial test flights and then maybe for Mr. Miyazawa's flight too in upcoming years. Thank you.
Yeah, I think It's really, I think you could still do 100 people. Like the pressurized volume on Starship is around 1,000 cubic meters. So if you had 100 people, you'd have 10 cubic meters per person, which is, you know, especially in like a 0G situation, that's actually quite a lot of room. Unlike a 1G situation, you only get to use one surface, really, live on one surface in a 1G situation, but in a 0G situation, you can live on 6 surfaces. You know, you can like all 6 sides of a cube. So things are way roomier than they may seem. And by the way, 1,000 cubic meters, I think, is close to what the space station pressurized volume is. So you know, Starship is like basically like launching space station pressurized volume on every flight. This is quite a lot. We can make it bigger if as needed, you know. Yeah.
Hi, Elon. Stephen Clark from Spaceflight Now. Thanks for taking our questions. We see the Starship prototype here, Mark 1. You talked a little bit about how you're going to build the super heavy vehicle. Can you update us a little bit more detail about how that development is going, where exactly it'll be built, and when we might see it on a test stand or on a pad?
Sure. Yeah. Good question. So the priority is to build at least 2 Starships at each site, at Boca and the Cape, and then start building the booster. So we'll complete, you know, Mach 1 through 4 before doing Mach 1 of the booster, and then we'll do, you know, Mach 1 and Mach 2 of the boosters at the Cape and Boca. The main constraint on launching the booster is engines, because obviously the booster has a lot of engines. So spooling up the Raptor production rate is extremely important to, vital, obviously, essential to completing the booster. Doing the tanks and the legs and, say, the grid fins, that is not a constraint. Like that we can get done fast. But we need, I think we'd want to have at least probably 24 engines, but I think really at least 31 engines to launch. So you add that up, you've got a lot of engines there. You know, we need for 4 Starships, we need well, these just have 3. Mach 1 and 2 just have three Raptor engines. Mach 3 and 4 will have 6. So you add them. This looks like a lot of engines, basically, including development engines. From now through orbit, we probably need 100 Raptor engines. And our production rates right now is maybe one every sort of 8 to 10 days. But it should be one every couple of days in a few months. And then our target is to get to a Raptor engine every day by Q1 next year, or sooner.
And if I may, when will we see people flying on this vehicle into space?
Well, I think we could potentially see people fly next year. You know, if we get to orbit in about 6 months, then and we have remember it's designed to be a reusable rocket, so a reusable booster, reusable ship, so we can do many flights to prove out the reliability very quickly. So whereas with an expendable vehicle, you have to build, if you want to do 10 flights, let's say, to prove out the viability of an expendable vehicle, you need to build and destroy 10 vehicles. Whereas we can do 10 flights, you know, within basically 10 days. So when I say rapid reusability, I mean, you know, you could fly it, you could fly the booster 20 times a day. You fly the ship 3 or 4 times a day. That's what I mean by reusability. And the only reason the ship it takes more time than that, more time than the booster, is that you need a couple of you need 3 or 4 orbits to synchronize for the ship so that it is over, you know, like I don't want to get into those complicated thing of orbital dynamics and the rotation of the Earth relative to satellite. But as anyone who's knows space, the track of a satellite, unless it's an equatorial satellite, is a sinusoidal track on the Earth. Unless it's equatorial or sun synchronous. So. Launching sort of due east, you have to kind of wait for the orbits to the ground path to sync up with the launch site, and that's the only reason it really takes maybe 6 hours or something like that to sync up and land back at Boca or the Cape. One of the really interesting things to contemplate is the total mass to orbit capability of a large reusable system where you have a significant fleet in operation. If you've got something like Starship where you've got maybe 150 tons capable to orbit, and the ship can fly, is capable of, say, theoretically flying 4 times a day, but they call it like 75% uptime, so theoretical 3 times a day, 365 days a year. So that's like about 1,000 flights a year for the ship. The booster can do a lot more than that. This is obviously max theoretical. And you've got 150 tons. That's 150,000 tons to orbit per year per ship. And if you've got, say, 10 ships, you would have 1.5 million tons to orbit per year. 20 ships, you got 3 million tons orbit a year. I think the total rest of world capacity, if you take all rockets on Earth, including Falcon, the total capacity to orbit, I think, is around 200 to 300 tons currently. Total Earth capacity to orbit is about 200 to 300 tons if all rockets launched at max rate. So we're talking about something that is, with a fleet of Starships, 1,000 times more than all Earth capacity combined. All other rockets combined would be 0.1%, including ours. But you kind of need that if you're going to build a city on Mars. So it's got to be done. It's got to be done.
Elon, hi, it's Bill Harwood with CBS News. I just wanted to follow up on an earlier question about life support systems, because that's not trivial, and obviously you're building a very sophisticated piece of hardware. Are you thinking about closed-loop regenerative systems? Are you thinking about developing these in-house, or are you looking at designs that already exist on space station, for example? And what are you shooting for initially? I know you're not going to be launching 100 people on your first flight, but what sort of a crew complement can we expect on those initial test flights, and how sophisticated does that life support system need to be? Thanks.
Yeah, I think for sure you'd want to have a regenerative life support system. So that just means you're recycling everything. That's for sure important if you're on a several months journey to Mars and then you're on the surface for 18 months. Regenerative is a kind of a necessity. So I don't think it's actually super hard to do that. Relative to the spacecraft itself, the life support system is pretty straightforward. Yeah, you just got to it's pretty straightforward. You got to take out the water vapor and the CO2, convert that back to O2. It's not super hard. The early flights of Starship would not have any people on board. It would just be in automatic mode. It would only be later flights that would have people on board. So I think even the first flights to Mars, we would send at least a couple of ships, have them just land automatically before sending people. Yeah.
Take about 2 more questions.
Hi, Elon. Eric Berger with Ars Technica. I would just argue the X-15 was the coolest plane of all time. And my question, I guess, is, we're not really used to seeing hardware built in less than a year. Can you talk about the timeline for this vehicle? Like, when you started fabricating it and how you went so quickly on it. Thank you.
Actually, I'm not sure. I think like up until October last year, we were pursuing a completely different design. So it was really, I switched the design to steel, I think, approximately maybe October last year. And then it's like, okay, so what's the fastest we can build a steel, ship in Texas? And then I think we built it in about 4 months or something, maybe 5 months. And then the ship, I think I'm not sure exactly when we started building it, but maybe about 4 months ago that we started building the ship, maybe 5. So it's been 4 or 5 months since we started building the ship from nothing, I think. Yeah, something like that.
And how did you go so fast?
Well, I have this mantra called, if the schedule's long, it's wrong. If it's tight, it's right. Yeah. And I just basically just go recursive improvement on schedule. And say with feedback loop, did this make it go faster? Okay, if it didn't, we're going to need to fix it. If the design takes a long time to build, it's the wrong design. This is the fundamental thing. Over and over, it's like the tendency is to complicate things. And I have another thing, which is like the best part is no part. The best process is no process. It weighs nothing, costs nothing, can't go wrong. So, as obvious as that sounds, the best part is no part. Like the thing I'm most impressed with when I have the design meetings at SpaceX is, what did you undesign? Undesigning is the best thing. Just delete it. That's the best thing. Yeah.
Hey Elon, Robin here from supercluster.com. My question is about potential fund synergy between SpaceX and your other projects. 1, is there a concept for a Tesla Mars rover? 2, are you going to be launching? Yeah, is there a concept already?
Well, actually, the Teslas will work on Mars. If you can you can just drive them pretty much, because electric cars don't need oxygen; they don't need air. So you can just drive them around, no problem.
Are you going to bring a boring machine to the moon or Mars?
I think that would be a good idea.
Me too.
Yeah, because you could just make as much room as you want underground, and you protect it from radiation and everything, and you can probably use the materials for building. And you need to mine ice and dirt anyway, so why not? Totally.
Thanks, Elon. And I don't believe you about the aliens.
I hope I'm wrong. I mean, I hope they're well, if they are here, I hope they're nice. They haven't killed us yet, so they must be not that bad. All right, any other questions?
Just one? Okay. Hi, Elon. I'm Martin Avignon from the SpaceX subreddit. We've crowdsourced a few questions. It sounds like I only have time for one, but oh well. I was wondering, could you elaborate on the number of engines that will be used for the boost back and entry burns on Starship, and what the dry landing weight of the Super Heavy will be?
Oh yeah, so Starship wouldn't really. There's the 20-kilometer thing, which is mostly. It's going to have 3 engines, but you only really need either 2 of them to work at any given point in time. But the ship, when it's in orbital operation, will only need a tiny bit of impulse to deorbit. You need a very tiny, less than 5% of the mass of the vehicle is needed to deorbit. So you just really puff one of the engines, and the main thing is trying to get the control. How do you shut off the thrust really precisely, so that you don't over or undershoot your target. For the booster has 7 engines that gimbal, and then the rest, whether it's a total of 31 or 37, are fixed. The fixed engines would not be used for boost back. So only the center 7 would be used for boost back. And then I really want to try to avoid an entry burn, if at all possible, That would, because that would, no, you have to have a high, the system has to be capable of a very high Q entry in order to avoid an entry burn. But I think we might be able to make the booster buff enough that it, it doesn't need an entry burn, hopefully. So then it just needs a landing burn. Thank you. Yeah. All right, great. Thanks, everyone. Thanks for coming. Hope you enjoyed it. All right.